Okay, so I think yesterday night you feel two big earthquake shakings. If you stay in Hsinchu, and based on the Central Weather Bureau report, as you can see, this is earthquake intensity distributions around the Taiwan, and the one earthquake occurred Hualien cities in here, and as you see in Hsinchu area, the earthquake intensity what we have the 3. Okay, so in our lab, and we put many sensors outside, and the sensor can capture the ground shakings anywhere. So as you see, this is the time series. The y-axis is the minute, and the x-axis is minutes, and the y-axis is hours. So as you see, there is local times around the 9 o'clock, 10 o'clock. So we see the big earthquake induce the large ground shakings at these moments. And there are many small earthquakes. You can see this is one aftershock and another one. And you can count all of the aftershock, how many aftershock we have. So totally around 30 aftershock just during yesterday night. So, but for the people, we only felt the ground shaking from the main shock, the large earthquake. But there are many following earthquake just occurred after main shock. So, so this is very important if we will go back to see our questions, our problems. So usually we put the oil in a tank, but we didn't know when and where the earthquake will be occurred. But we need to design some idea if earthquake coming, and we need to design some structures and to avoid the hazards induced by the earthquake. So this is a very simple problem. We put the oil liquid in a tank and have the height is 4.4. The height is 4.4. And you see the total height of the tank is 5. If the ground shaking induced by earthquake and the liquid of the oil level 9 will change it. If this level 9 higher than 5 meters, the oil will flow out. So we need to avoid these problems. So we need to consider how large ground shaking will induce by the earthquake. Even though the earthquake didn't happen, but we need to guess how large it is. So for this acceleration, we know the 1g is 9.81, right? So the 1.2 is around maybe smaller than 0.1 g, but it's just around the 0.1 g. So the 0.1 g, if you convert to the earthquake intensity around 4, if you convert to earthquake intensity, as I show the Central Weather Bureau report, in Hsinchu area, our intensity is 3. So if your accelerations induced by earthquake around these numbers is equal to intensity 4. So the ground shaking will higher than yesterday you are located in Hsinchu. So in that province, can we, based on this condition, can we predict how change of the liquid height? As the figure showing here, H1 and H2, how change it is. For the initial H1 and H2 are 4.4 meters. But if one earthquake coming, how change they are? Okay, so we need to decide what is the H1 and the H2 height. Okay, so based on the idea, we exactly know we have the AX. AX is the horizontal acceleration showing here is 1.2 meter per second square. And then this is what is the S? S is means the straight line directions along the water liquid surface levels. So we know based on Euler's equations, so we can write the government equation like this, and the piezometric pressure should be changed with along the straight line, and it will be equal to the density multiplied the acceleration along the straight line, and there have additional minus in left hand side. Okay, so we just mark the level in here is 1, and the level water level point in here is 2, and there is a connection to the ambient environment. So we know the point 1 and the point 2 is posed on the air. It's posed on the air. So we do the integration for this one. Again, so we start from the 1 to 2 along the straight line, and we do the integration for the piezometric pressures in here. And the ds we move to the right hand side. So we have a low AS, and we assume the horizontal acceleration from earthquake is constant, but in true condition not constant. But we assume the acceleration from earthquake is constant values. So we can put the AS outside the integrations, and the inside only have the DS. S is from 1 to 2. So it's along the water level lines from the 1 point to the point. Okay, so we do the integration, so we know the minus, and we have the P2 plus gamma Z2. But here I don't use the Z because in our question we use the H2 as the height at the location point 2. So here I just replace the Z to H2 because this is our height in here. Okay, and we know we need to minus the point at 1. So this is P1 plus gamma H1. And then the right hand side is low AS. And DS we know is the distance from point 1 and 2 along the straight line. So I use the capital S. Okay, that means the length from the point 1 to 2. Okay, so and we can cancel out some things because the P1 and the P2 point is posed on the air. So the gauge pressure is equal 0. So we don't have the P2 and we don't have the P1. So what we only have the minus gamma H2 and the minus plus. So we have the gamma H1 and equal to rho AS and the capital S. So we only have the length in here is equal to 8 meters. So we need to convert the L with the angle here, and we can have the S distance. So we exactly know the cosine theta. The theta is in here. So we exactly know the cosine theta is equal to S over L, right? We have the L and we don't have the S. So we know the S is equal to L divided cosine theta. Okay? So we exactly know the the S. And the seconds, we don't have the AS because we don't have the acceleration along the straight line. We only have the AX. Where is the AX? AX is along these directions. So we only have the AX. So the AX, if multiply the cosine theta, and then we can project the AX acceleration directions convert to the S directions with the cosine theta. Okay, so we have the AS. So we have the S and we have the AS. So just put into the equations on the right hand side. So here the AS is AX cosine theta. And the capital S in here is L divided cosine theta. So in that way, the cosine theta can cancel out. So what do you only have? And here, the left-hand side, the minus gamma. The gamma, usually we use the low G. Okay? So the inside, maybe here I use the positive sign in here. So the inside, we only have the H1 minus H2, right? We only have H1 minus H2. And the right-hand side, we only have the low AX multiply L. L is horizontal length in here. Okay? So you can cancel out something like the density of the oil. And so finally, you know, you can H1 minus H2, and the length I move to the left-hand side to become here, and it's equal to the AX divided G, right? And you follow the ratio showing here. This H1 minus H2, so it's a length in here, right? H1 minus H2, so the length in here, and divided the L, so this is equal to the tangent theta, right? Because H minus 1, H1 minus H2 divided L is equal to tangent theta. So for this kind of the problem, we can have this relationship very quickly if we can observe the tangent, the theta in here. So we just use the tangent theta should be equal to the acceleration for the horizontal divided the 1g. So we don't need to follow the Euler equation repeatedly because we already know the final form in here. So the final, we have the tangent theta, and we know the tangent theta is H1 minus H2 divided L, and actually is equal to AX divided G. So we have the equation 1. But we have two unknown parameters. We only have one question. We only have one equation. We cannot solve two unknown parameters. So we need additional equation. And then we have two equations, and we can solve the two unknown parameters. So what is two equation? Another equation is, because all of the oil in the tank, so the volume of the oil didn't change. The total volume of the oil didn't change. So before earthquake coming, we know the volumes in here is 8 meters multiply the depth 4.4. But we didn't know the width of the tank. We use the W is the width of the tank. So this is the volume oil before earthquake. And after the earthquake comes, and our liquid profile become the trapezoidal shape. so we can compute the trapezoidal areas. So we have the H1 and we have the H2. We have the H1 and we have the H2, and the height is L. Okay, and divided 2. This is the area for the trapezoidal shape, and then we have the same width of the oil liquid. Okay, so this is our equation 2. So you have the two equations. So and you have the two unknown parameter H1 and H2. So you can solve the problems in here. Okay, so you can compute by yourself, and then finally you can determine the H1 and the H2. And you see here the H1 is 4.89 meters. It's quite close to the 5. If the H1 higher than 5, the oil will flow out. It's not make sense because we cannot let the oil flow out. So if the earthquake become bigger, it is possible to let the oil flow out. It's very dangerous. Okay, so if you would like to avoid this problem, you need to have the higher tank, much higher tank, and then you can avoid these problems. And the second question is, how large pressures at the bottom of the tank? So we have the B point, we have the A point. So as we know the high, oil high at the point B, and we know the oil high at the point A. So we just follow the hydrostatic equations. We have the high, and we know the gamma oils, so we can compute the pressures. Follow these equations. So this is around the 30 and the 40 kilopascals. Okay, 1 ATM is equal to 101.3 kilopascals. So it's almost the 3/1 times of the 1 ATM. Okay, so as I show example in here, it's very simple, and we just follow the Euler equation, and we can solve these problems. But this problem we always meet in practical conditions. We cannot guess where and when the earthquake will occur, but we need to design some ideas based on some assumptions. So for these questions, we based on these assumptions. Maybe in Hsinchu area, the large earthquake intensity around the 3 to 4. So if I put the oil tank in here, so we need to assume the largest ground shaking induced by the earthquake will happen in the futures. And then if we design, I need to, based on this condition, to design some infrastructures or other oil tank. Okay, so Euler equation is very important. Today our quiz will have the one questions follow Euler equations. So you didn't know how to use the Euler equation, so you need to look your textbook and remind you how to use the Euler equations. Okay, so we still have the okay, so maybe stop here because so close the book, and we have the paper in here. Okay.我们今天的问题，助教自己做都会有一些小错误，所以我就想花多一点时间跟大家解释一下题目。哦。